Hello everyone, welcome to this video. In this video we'll be looking at the symmetry of a square. Now you are familiar with the basics for this subject, and now why studying symmetries of a square is important. It is important because whole of the group theory, in fact the abstract algebra, that is based on symmetries. Many of the artists and painters, they were looking at symmetries which are having certain shapes, like the shape of a circle, square, rectangle, and various other objects and shapes, designs, where we have the concept of symmetry. So in order to understand these groups, we first of all be looking at the symmetries of a square. So now in this video we will be just looking at the symmetries for squares. So let's get started here. Suppose you are given a square, correct? Suppose this is the given square. Now how can we describe all possible ways in which this square object can be repositioned? So can we place it like this, or like this, or like this, so that a different position would give you different way to represent this square object? So can we have different ways in which we can reposition it? So the answer is yes. So for that, what we'll be doing, we are just marking this given square with 4 points, which I am saying the left upper corner is marked with the color green, then the right upper portion is marked with blue, the left lower portion is marked with red, and the right lower portion is marked with the color pink, right? So in order to describe and discuss these positions, let us mark them by different colors, right? So let's move further to see how we can define the symmetry. So the first operation that you could apply here onto the square is, given this square here, you are given this particular square here. Now if you apply the operation R0, now what does this R0 means? R0 means you are rotating the square by 0 degree. What does that mean? Eventually it means you are doing nothing on to this square and you are just keeping it as such. So in terms of rotation, you could say we are performing a rotation of 0 degree. So if you keep it same, we will have the same square back, correct? Now next move on to the second operation here. Suppose in this case, in the second case, you are given this square here. For this particular square, we are performing the operation of rotation, and we are performing this rotation at 90 degree, and we are doing it in anti-clockwise direction, right? If this is the operation that we are defining, so basically we are moving it like this by 90 degrees. So what will happen? Actually this color would move here at 90 degree angle, this color would move here, this color would move here, this color would move here, right? Basically, so what you are doing, you are tilting this square by 90 degrees, and you know all the angles of a square, they are at 90 degrees. So basically we just have to tilt it once, so that this corner would come at this corner here, correct? So that your transformed square would look something like this. Every color would be shifted once by making a rotation of 90 degree. Next, let's see, when we perform the rotation of 180 degree, what would happen? Now for performing the rotation of 180 degree, what you have to do, you have to rotate the square twice by 90 degree, right? So that means whatever you were doing here onto this square, so that after a rotation of 90 degree you were getting this square. Now onto the square, if you again apply the rotation of R90, so you will end up at this square here, right? So you see this color now would be moved here, this color would be moved here, this color would be moved here, this color would be moved here, so that you will have this square here. So initially that is the same as saying that if we start from the given square, you will rotate it now by 180 degree, or you are saying you will rotate it by 90 degree twice, right? So this is the end result that we would be obtaining after we make a anti-clockwise rotation of 180 degree. Next, we'll be making a rotation of 270 degrees. So here, in order to make a rotation of 270 degree, that is simply obtained by moving this particular square at an angle of 270 degrees. So that means you will be shifting this corner, now not here, but here. So you will be rotating it in such a way that this corner would, after 270 rotation, would come here at this particular point. Or another thing that you could perform is, you start from here, you have this square, perform a rotation of 90 degree, you will get this square, then perform a rotation of 90 degree, you will get this square, and then perform a rotation of 90 degree, you will get this final result. So this is how you can obtain this final result by making a rotation of 270 degree. So these are the 4 operations by which you can rotate your square so that you would have different orientations for this particular square. So that means your square would be positioned in different manner. Correct? Now what other things we can do with this square? Now you have to think that the first thing that we can do is we can flip it. How we can flip it? There are many ways to flip it. The first way is by flipping it about the horizontal axis. Now what is this horizontal axis? Suppose we have this line which with a horizontal line, a line such that it divides the given square into 2 equal parts, right? Now about this line, if you are to rotate, so that means whole of this upper portion would come to the lower side and whole of this lower portion would come to the upper side. You can imagine this by making a square out of a paper, right? So when you flip, so what would happen? This the color blue would come in place of pink, and pink will go in place of blue. And similarly, the same would happen for green and red as well. Green will come down, red will go up, right? So this is flip about horizontal axis. Similarly, what we can do, instead of taking this horizontal axis, now we can take this vertical axis, right? If you take this vertical axis here, what will you have? That means now you are making a flip about this line, this vertical line. So that means this green color would go here, blue color would come here, right? That is taking a mirror and just superimposing it. So this thing would go there, this thing would come here, right? And similarly, this red would come in place of pink and pink will come in place of red. So this is the flip about vertical axis. And similar manner, we can flip it about the main diagonal. So you see, this is your main diagonal. So when you are flipping it like this, so basically what you are doing, you are taking all the elements here to this side and all the elements here to this side. So in this case, obviously green and pink would be at the same position. Why? Because we are not when you flip it, you see the half portion of green would come here, half portion of green would come here. So basically it would just be a green ball, green color marked here, right? So you see, just this blue will come here and this red will go there. Similarly, when you make a flip about the other diagonal, let's call that by D dash. So the other diagonal is this one. So this time the colors red and blue would be kept fixed, whereas this green and pink would exchange their places, right? So these are various symmetries which you would obtain for a square. Now in the next video, we will be seeing how we can apply different operations onto these different squares with different operations that we have defined. Well, that is it for this video. Thank you for watching.